Today we'll use JK flip-flop to design the sequence detector in the previous lecture I have given using D flip-flop. Okay, let's begin then. So, so the question was, if you recall, so design a circuit that detects three or more consecutive ones in a string of bits coming through an input line. So the first step is to draw the state diagram, which is something like this. It is actually described in the previous lecture. You can go and see that. But today I'll just skip this state diagram drawing part and move on with the state table for JK flip-flop. Now let's consider that the table. Okay, let's try to just go to a blank slide. It will be better for you guys. Okay, now let's start. So we'll be needing a present state first, right? The present state. Okay, let me do this. So present state, then the input, present state input, then the next state, then the output. Okay, so remember, I have actually discussed this same design using D flip-flop in a previous lecture. Okay, so for present state, okay, so you can easily see that there are 1, 2, 3, 4 states. So I definitely be needing at least 2 bits to mention all the 4 states. So say for example, like this would be 00, this would be 01, 10, 11. Say, so 00, that means I would be needing at least 2 flip-flops. So 2 flip-flops, again I'm just naming them, uh 1 and 2, flip-flop number 1 and 2. So q1, q0, then the input x, the next state is q1 star and q0 star. The output, say for example, the output name is something like this. Okay, so okay, I think we're good. So just fill up the q1, q0 and x uh, using the 8 combinations as discussed before. 0 0 0 0 0 0 0 1 0 1 0 0 0 1 1 1 0 0 1 0 1 1 1. Okay, so now these are the 8 combinations using the 3 bits in present state and the input. Okay, now I know the state diagram, so I can easily guess the next state. So if you recall from this state diagram right here, that is, say for example, I have considered this to be 00 state. This is 01, this is 10, and this is 11. Okay, so in that case, see that 00, if I give input 0 at this state, it remains in 00. If I give a input of 1 at 00, then it moves towards 01. Okay, so this is the basic principle. When I'll be getting a 1, then I will be moving towards the next state. Otherwise I will come back to the initial state, that is 00. So 00, I'm giving input 0, so it is 0 0. So when it is input 1, then it goes to 0 1. But when the present state is 0 1, I'm giving 0 0, so it goes back to initial state. And here it is moving towards the next state, goes back to initial state. Now here it is moving towards the next state, that is this one, right? So again goes back to the initial state, staying at this state. if you recall properly, that you need to actually detect three or more consecutives in at the last state or last condition. It fulfills the more consecutive ones coming through the input line. Okay, so the output will be 0 at every position till when I reach this one, this state, right? So I'll be getting all. So this will be 0 and this one will be again 1, right? So this is my state table, but to be fair, it's not the total state tables yet. I'll be showing you why. So because I will be needing to select the type of flip-flop. Say for example, I know that I have already determined that I will be using JK flip-flop. So in order to use JK flip-flop, we need to JK flip flop, right? So say for example, there is two input for each JK flip flop. One is J and K, right? So another is J and K. So two JK. So one is J1 K1, or there is J0 K0. I don't know how good I'll be able to explain using this, but I'll try my best, level best. Okay, now in order to understand what will be the inputs of J1 and K1 or J0 and K0, you need to understand how an excitation table is formed. So see that these were the excitation tables. I'll just make you understand how the excitation table of JK flip-flop comes. Okay, so see that in this case, in this particular case, see that the current scenario is, you know the present state, you know the next state. The problem is you don't know the inputs of J and K. Okay, so if you see, so if I draw make a table like that, I'll be knowing the present state, I'll be knowing the next state, but I don't know J and K, right? Okay, so see that these 2 bits I'll be knowing them. So 2 bits gives you roughly 4 combinations: 0 0 0 1 1 0 1 1, right? So now what will be the values of J and K? You need to figure this one out. Okay, fine. So how we do it, will be using this equation, to be exact. Q star, or next state, is equals to JQ prime plus K prime Q. So I'll put this combination into this to get J and K. By how? Let's try this one. So see that, so just skip this one. So let's see that. Okay, fine. So the value of Q star is 0. Okay, fine. So I'll put 0 here. Okay, is equals to, and Q is also 0, so that means this will be 1. So this remains J, and Q is 0, so this becomes 0. So that your J is equals to 0, right? Your J is equals to 0. So at this point you get the value of J is equals to 0. But see that one thing, that your K is vanished. As your K is vanished, it is don't care. Okay, when any variable will be vanished, then you need to consider that to be as don't care. As simple as it is. And for the next one, you can easily understand what I'm going to do. So this one will be 1, because the value of Q star is 1, and everything will be same. This will be this will give me the value of J to be 1, J to be 1, and again, so K is vanished, so it will be don't care again. In similar manner, we'll be completing the whole thing. So for another example, I'll just show you another example of it. Okay, so for the last combination, if I put this, see that it becomes 1. okay, and this becomes 0, okay, and this becomes k prime, right? This becomes k prime, so k prime is equals to 1. So see that k prime is equals to 1. So what is the value of k? K is equals to 0, definitely. So see that now j is vanished, so j is vanished, so j is vanished, so j is don't care, and k is 0. So hopefully this will be the case for the other combination. So if you go and check this one, so see that I have actually found that one: 0 don't care, 0 don't care, 1 don't care, 1 don't care, x1 x1 x1, or don't care 1 don't care 0, right? Don't care 0, don't care 0. So this is how our excitation table is formed. Now see that you need to just know the present state and the next state. Okay, just okay, let me remember it. Okay, uh, I'll be using this one again. Okay, I'll be coming back and using this one over and over again. So to so now see that, so I'll be finding the inputs of j1 and k1 right now. So let's try to do that. So for j1 and k1, for this first flip-flop right here, j and k1, I'll be using q1 and q1 star, so present state and present next state. So 0 0, so what should be j1 and k1? So let's go. So 0 0 gives you the value of j to be 0 and k is don't care. So j is 0 and k is don't care. So again 0 0, so it is again 0 don't care. So 0 again 0, so that's good, 0 don't care. So 0 1, now it's 0 1. Okay, let's move. So 0 1, it's 1 don't care. Okay, it's 1 don't care. Okay, now then 1, so present state is 1 1 0. So 1 0 don't care 1. Okay, 1 0 don't care 1. Then 1 1 1, right? 1 1, so then it will be don't care 0. So 1 0 again, 1 0 1 0 produces don't care 1, right? So 1 1 1 1 produces don't care 0, right? Okay, so you can understand how it should be done, I guess. So now in similar manner, let's do the j0 k0. Okay, in order to do that, I'll be using q0 q0. So present state and next state, I'll be doing completing this one right here. Okay, now do this, let's do this. So 0 0 will give you 0 don't care, 0 1 will give you 0 1, right? 0 1 will give you 1 don't care, right? 0 1, let's go and check. 0 1 give you 1 don't care, right? So 1 0 1 0 1 0 will give you what? 1 0 will give you don't care 1, don't care 1 1 0 again, so don't care 1, that's good. 0 0 0, right? 0 0 will give you 0 don't care, right? So 0 1 will give you 1 don't care. Then 1 0 1 0 again, 1 0 will give you don't care 1, don't care 1, 1 1 will give you don't care 0, don't care 0. So that's that. So okay, so this is my state table for the JK flip-flop. Now I'll be using the inputs of J1 and K1 and J0 and K0 and do the K map and find the equations for uh, the J1 and K1. Okay, now let's do that. Let's use the next page, then this one. Let's use this one. So I am erasing all the things. I'll be using this page to do that, to do the K-map more specifically. Sorry. Okay. So where were we? Okay.